So we're going to look at three things today. We're going to look at shifting, reflecting, and stretching. Now stretching goes both ways. You can stretch horizontally or vertically. Vertically goes up and down, horizontally goes left and right, as you guys know. First, let's look at shifting. So this is the shifting stuff. And actually, if I were to write this textbook, I probably wouldn't write these all separate. Actually, it kind of helps explaining it, but this is what it's saying. F function, the f of x right here, that's your general function, whatever it is. There's a bunch of different general functions. You guys know there's the square root function, there's the constant function, there's the quadratic function. They all have different shapes. If you guys look in the previous section in 2.4, it gives you a picture of those. Or you can look at the handout that I gave to you guys yesterday. All right, so we're going to take this function h. And this function h is going to take the general function and it's going to add a constant to it. That's what the c represents. A constant is just a number. It can be an integer, it can be a fraction, it's just a number. It's a number without a variable. So let's say it's 2. This says plus 2. It's going to take the function and it's going to add 2 to it. Now if it adds 2 to it, some of you guys might know what's happening because you're understanding what you just did in 2.4 and what we just did in the warm-up. If you add something to the function, then it'll make it go up. If you subtract something to the function, then it'll make it go down. It'll shift it up or it'll shift it down. Now, inside here, it does something a little different. While these ones right here add and subtract to the function, this is adding and subtracting to what? The x. It's right there in front of you. See, it says x minus c, and this says x plus c. So that's adding and subtracting to the x, to the domain numbers. Now this is weird because if you see minus c, and you're thinking about shifting, and you're thinking about your graph right here, and your graph is a quadratic, and if you see plus c, which way do you think your graph is going to shift? Is it going to shift to the right or to the left? Yeah, you would think it shifts to the right, correct? But you can't. It doesn't. It shifts it to the left. You have to think the opposite when it's happening to the x. See, that's what it says right here. When it's adding a constant to the x, it shifts it to the left. Whenever it's doing it to the domain number, the x, you got to think the opposite. So let's look at an example. So here I got this right out of the book, guys. Here we have our parent function, or our general function. What is it? What do you guys know what the name of it is? It's a cubic. It's a cubic function. It's not a cubed root. Cubed root is different. That's this, and it has a 3 right there. This is not a cubed root. This is just a cubic. It raised anything to the 3rd power. So this is the general function. You see it right here? Now, what is this minus 1 going to do to the general function? What's it going to do to it? It's going to make it go down. So this one will go down 1. And in fact, if you don't want to write stuff, you can say arrow 1. So arrow down 1. I'm down with the arrows. Okay. Now over here we have a plus 1. So what's this plus 1 going to do to the function?
Make it go up.
Yeah, this plus 1 will say up 1. It'll move the function up 1. But this function also has a plus 2 right here on the x. Now the plus 2 is going to do something different because it's doing it to the x. Which way is it going to shift it? Yeah, that will shift to the left. So I'm going to point an arrow to the left. Left how many? 2. And that's it. Alright, so that was shifting. Now we're going to look at reflecting. Now reflecting, the way things reflect is by throwing a negative in the function somewhere. Okay? So look at this first one. This time our h function is going to take the general function, the f function, and it's going to put a negative, take the opposite of the function. So the whole function is the opposite of what it was. So what does that do to the function? Well, do you guys know what f of x is the same as?
Y.
That's the same as y. So it takes all the y's and it makes them opposite. So if you look at the graph, it would have let's see. If it had a point right here, and then you slap a negative on the f of x, where would this point now be? It'll be up here. And so this reflects in the x-axis. It reflects in the x-axis. Okay, so it goes from here to here, or from here to here. Okay, it reflects in the x-axis. It just goes across the in the x-axis, and that's what that reflection does. The other one, this one, where the negative is on the x, guess what that's going to change? Yeah, so let's do the same thing. We'll have our graph right here, but this time our point is right here, and because it's on the x, it'll put it over here. So it goes in the y-axis this time. So it goes from one side to the other side. And so how does that look with a function? Well, let's see. The easiest function to study shifts and reflections on is this one, the square root function. Okay? So let's look at this first one. So there's our general function, the square root of x, has a negative on front of it. Well, what does the square root of x look like? First, let's graph that. The square root of x looks like this guy right here. It just looks like this. He goes like that. Looks like a plane taking off, I guess. So if you had a negative on the function that's on the y's, how does that change our function? It flips it which way? It's going to flip it this way, across the x-axis. So it's going to go this way. It used to be right here, but then it flipped it. The negative flipped it. All right, look at this one. This time the negative is on the x. How's that going to change it? This is where it was, but now all the x values change. So the point that was over here is now going to be over here. So how's that going to make my function look? When it was this x, now it's this x, because it changed the sign of it, right? It changed the sign of the x. So your graph is going to look like this. Now it points the other way. Does that make sense? No? All right. And now we have a shift and a reflection. So here's our shift, and now here's a reflection. Okay, whenever you do the reflection, you always do it after all the shift. Oh, that sounded really bad, huh? It said shift, guys. Come on. Whenever you do the shift. Thanks a lot. Now it's on my video. If you guys didn't laugh, people wouldn't notice it. Okay. You always do the shift first. So the shift says +2. But that +2 is on what? Is that on the y or the x? It's on the x. And it's inside. So since it's on the x, you have to think the opposite. So is it going to move it to the left or right? It's going to move it to the left. So this goes to the left too. And then this reflection is on what? Is that going to be in the x-axis or in the y-axis? Think about it. What does this change? It changes which values? The x values or the y values? It changes the y values. So if it changes the y values, it goes from top to bottom, bottom to top. So here, check it out. This is what it's going to look like. If this is my parent, or my general function, here, I'm going to put it in black. The 2 is going to shift it this way, right? But then I have to do the reflection. The reflection is changing the y's. So if the y's were here, now they're here, right? Because you go from top to bottom or bottom to top. And so your function is going to look like this. So it moved it over, and then it reflected it down. Reflected it in the x-axis. Now we're going to look at stretching. Okay? Stretching is when you multiply to the function. Okay? When you multiply a number to the function, it changes it. So the book doesn't have this, but I would write it something like this. The h of x function, if it's stretched, it would have a c, a constant, multiplying to the general function. I should probably put a dot right there for multiplying. This c stretches it. It's going to stretch it vertically or horizontally. Another way to say it is making it taller or making it shorter. It doesn't matter. You're just explaining the characteristics of the change of the graph. It doesn't have to be really specific, just as long as I understand what you're saying. So check out this one right here. That is, which function is that? Do you guys know what this is called? Absolute value. So when I graph that one, let's see. Let's graph the general function. The general function goes like this. Boom. It looks like a V. Okay. All right. Because I multiplied by 3, think about it. If I plug in 0, it's still going to be 0. If I plug in 1, it's no longer just going to go from 1 to 1. It's going to go from 1 to 3. And from -1 to 3. And so it goes like this. See how much thinner it is? It stretches it vertically. So you can call this a verti stretch. Or you can say it gets taller. I like both of these descriptions. The one? Oh, I'm just graphing points. I'm just plugging in random points to this so I get an idea of what my graph looks like. But I picked 1 because if I picked something like 5 or 4 right there, it's going to be, you know, up here, and that's not really going to be on my graph, right? I'm not going to do that. Because if I pick 4, what's 4 times 3? 12. That's going to be way up there. It's not on my graph, so I'm not going to pick 4. That's why I picked 1s. Okay, let's look at the next one. The next one has a 1/3. Ooh, 1/3 is like dividing it by what?
3.
Yeah, if I multiply by 1/3, it's like dividing it by 3. So check this out. If I plug in a 1 to this, well, first let's plug in a 0. Plug in a 0, you get 0, right? The absolute value is 0, 0, then you multiply by 1/3 is 0. Okay, did that one, got out of the way. Now 1. 1 times 1/3 is 1/3. So you go to right there. And -1 would be right there. If you plug in 2, that's going to be 2/3, right? So it's not even at 1 yet. Oops. So your graph looks something like this. You see how it stretches it horizontally? This is a hori stretch. Just on a roll today, aren't I? Horizontal stretch. Or you can say it gets shorter. I like both. I just want to show you this one more thing because I think it's written weird. Look at this.
Oh, because the number is inside the
Yeah, look at this number's inside. It's multiplying the inside. And this number's inside also. So what's that going to change? This time it's not multiplying to the function. It's multiplying to what? It's multiplying to x. And so this will also stretch it. But it stretches it differently. And honestly, the best way to see it is by actually making a table. Yeah? I'll talk more about this one tomorrow on the next video.